Hi everyone, it's Mr. Kwan here. Today we're going to be talking about matrices. Now, a matrix, or the plural form, which is matrices, is a rectangular array or table of numbers, symbols, or expressions arranged in rows and columns. Two matrices are said to have the same order or dimension, in other words, be the same size if they have the same number of rows and the same number of columns. The numbers inside of a matrix are called entries, or the elements of a matrix. If a matrix has the same number of rows as columns, it is called a square matrix. A matrix with one row is called a row matrix. A matrix with one column is called a column matrix, and both of these are examples of what are also called vectors. So when the columns and rows of a matrix A are interchanged to create a matrix B and vice versa, we say that A and B are transposes of each other. Now, the notation for transpose looks like this. So normally matrices, we define them with a capital letter. So if you have a matrix A and you want to take the transpose of it, in the superscript, which is kind of like an exponent, you would put a capital T, and that is the mathematical notation, and the way we read it is A transpose, like that. All right, so let's look at our first example. It says, consider the matrix A and B defined below. Use them to answer the following questions. Now, a couple of things that I'd like you to notice. If you look at matrix A, it is the entries of that matrix are enclosed by parentheses, and if you look at matrix B, the entries are enclosed by brackets. Parentheses and brackets, when talking about matrices, are used interchangeably. So you will see both parentheses and brackets just depending on what textbook you're looking at or who you are talking to, but you can use either one. So let's look at matrix A. Maybe we'll talk about the dimensions first. And the way that we talk about the dimensions is we say that it is a 3 by 3 matrix, and we write it 3 kind of like a multiplication or X symbol, and then 3, and that denotes the number of rows and the number of columns. Now, these both happen to be square matrices since the number of rows and columns are the same. However, when something's not a square matrix, how do you know when you're talking about the dimension which one to describe first, the rows or the columns? Well, the standard is that it's the dimension is the number of rows by the number of columns, and students often get that mixed up, and the mnemonic device that I give students to remember the order of the dimension is if you take the first letter of each word, it's RC, and I don't know if it's still around because I don't drink soda anymore, but there is a brand of soda called RC soda. They're just a brand of soda pop. And so that's always how I remember the order in which you talk about the dimension. I think RC is also short for Royal Crown sometimes, so that's another mnemonic device that you can use. Okay, so note that the B matrix is also a 3 by 3 matrix because it has 3 rows and 3 columns. So part A of this example says, what numeric value is represented by lowercase a, and then the subscript says 2, 3. Now, I told you earlier that we use capital letters to denote a matrix. Lowercase letters are usually used to describe a specific element of that matrix. So the fact that we have a lowercase a here means that we want to be looking at the capital A matrix, and the subscripts 2, 3 means that we want to look at the number that's in the position where it's the second row and the third column. So going over to our A matrix, we want to find the second row, which is here, and we want to find the third column, which is here. And so the element that we are looking for is going to be the 2 there. So we can say that A subscript 2, 3 is equal to 2, because that is the value that is in the second row and third column. Okay. So part B of this example asks us to find A transpose. And what that means is we want to take all of the rows and columns and basically swap them. So we're going to say A transpose equals, it's still going to be a square 3 by 3 matrix, but now the first row is going to become the first column. So the entries for the first row are -1, 0, 3. And so now I'm going to make those the values of my first column. And then the values of the second row in order are 1, -2, 2. So that's going to be my second column now. So 1, -2, 2. And then my last row or third row, the entries in order are 7, 0, 3. So now those are going to be the values of my third column. So that is how you would find A transpose, is that new matrix right there. Okay, let's move on to example C. All right, so if we want to subtract 2 matrices, we have to make sure that they are of the same dimension, which in this case they are. Both A and B are 3 by 3 matrices. And how you would subtract matrices is you would subtract them with the corresponding element or entry in the other matrix. So let me just quickly rewrite the 2 matrices that we have. So A is -1, 0, 3, 1, -2, 2, and 7, 0, 3. And B is equal to -1, 0, 3, 1, -2, 2, 7, 0, 4. Okay, so then A minus B is going to be the matrix, and we're just going to subtract the corresponding values. And so if I were to write that like symbolically, in the first entry it would be A11 minus B11, and then in the next row it would be A21 minus B21, and then the next value would be A31 minus B31, and in the first row second column it would be A12 minus B12, and so on and so forth. And so if we did those, then you'll see that it's -1 minus -1, 0 minus 0, 3 minus 3, 1 minus 1, -2 minus -2, 2 minus 2, 7 minus 7, 0 minus 0, and 3 minus 4. So our resulting matrix is going to be 0, 0, 0, 0, 0, 0, 0, 0, -1. That was a lot of writing, but this is our final answer. So A minus B gives us that matrix there, and notice that the entry in the third row and the third column is -1. However, if that happened to be a 0, then that is called the 0 matrix. So this is kind of a side note, but the 0 matrix is a matrix where all the entries are 0. Again, notice that this is not a 0 matrix since the third row and the third column value is -1, but if it was a 0, then the whole thing would be a 0 matrix. All right, let's move on to part D. It wants us to find A plus B transpose. So before we do anything, it would probably be helpful if we figured out B transpose. And so just like we did in a previous example, we want to switch the rows and the columns. So let me do that quickly here. Okay. So now we want to add that with our A matrix. So A plus B transpose is going to equal, let's see, so -1 plus -1 is -2, 1 plus 0 is 1, 7 plus 3 is 10, 0 plus 1 is 1, -2 plus -2 is -4, 0 plus 2 is 2, 7 plus 3 is 10, 2 plus 0 is 2, and 4 plus 3 is 7. Okay, so this is our final answer. So that is the matrix A plus B transpose.